let's see. Let me share. Let me share the browser. And then we'll go to that out of the way. Okay, we have to go to Brightspace. Here we go. All right. So our lab is 578, I believe. That's ours. No, 576. Right? 578. 578. There we go. Okay. Everybody looked around in the Brightspace so far, and you know roughly where everything is. The only reason I'm going in here is to emphasize a few things, right? Everybody got my message about tutoring. Berry Pine's available for tutoring. And if we go into assignments, are going to show you all the labs. Right, so we have several things that are due. First one's due on the 9th, I believe. Yeah, lab notebook check. This first lab notebook check, all I want to see there is, and you have any trouble finding these types of notebooks with the quadriline pages in them? Got good, okay. All I need to see for that first lab notebook check is, and it's kind of hard to write on this surface if you haven't noticed. Even Sharpies might give you trouble. So if that's the case, then you can write on the inside. But somewhere, I need your name, the class you're in, CHEM103, and the semester. That identifies what this belongs to. And then go in and every page, the top right or the top left corner in ink, number them. 1 to whatever. They used to be 200, but I think there's a lot less now. I know it's boring, but number every page from the first page to the last. And then on the first page, or you could do it on the third page, that means that every right-hand facing page is going to be odd numbered, and every left-hand facing page is going to be even numbered. So if you're running along and you get distracted and you come along here and you're starting to put even numbers on the right-hand side, stop. Okay, go back and find out where you skipped a page. And by the way, if you have a mistake in your lab notebook anywhere, you're going to write in ink. So if there's a mistake, you just cross through it, initial it, and make the correction. If it's a small correction, you should be able to put it right there by the mistake. It's a big correction with big old line X through your work, initial that, and then either on the next page or the facing page, you put the correction. Now, what you want to do is, as you're filling in your notebook, in the beginning, only write on the right-hand side. Leave the left-hand pages free. That's for big corrections, for overflow. If you've already got stuff on the next page, and you want to keep it contiguous with the work that's being done, then you have that left-hand page to write on. Or you can draw graphs there. And that's why they're quadriline, so you can put graphs in here. Okay, that's what you do with corrections. And I would suggest that as you write things in here, preparing for a lab, we'll talk about that in a minute, every other line, so that you'll have room to make corrections if you need them. Okay, so you don't get bunched up. And everything that happens in the lab, before, during, and after, goes in here. Right? The only hard copies that you're going to use for the lab and turning it in are the one we're going to do today, graphing. And let's see, I was looking for another. No, not this semester. Okay, so the only, oh, lab techniques. That's right. The first two. Graphing techniques is the first lab. Lab techniques is the second lab, and those are informal labs. So you will answer questions and you just turn the hard copy back in to me. Okay. That gives you time to set up your notebook, get your notebook, get it set up and ready for the third lab, which starts the formal lab. Right. We'll talk about the difference between informal is obvious. It's like any other lab you've ever taken where they give you a hard copy, you just fill stuff out and hand it back in. Okay. But the rest of them are going to be formal lab reports. Okay. We'll talk about those in more detail in just a minute. But that's how you set up your lab notebook, right? That information, number every page, right? And then go to the first page or maybe the third page if you want and write your table of contents. That's all you need for the first lab notebook check to see if you've got it ready to go to business. When we get to the point where we're going to, and the informal lab reports, you don't have to put anything in here for them unless you want to. If you want to put stuff in here, like get practice for doing your informal labs, you just write the title of the lab in your table of contents and the page it starts on. And then you go over to that page and you put the title. Now, if we're doing a formal lab report, there's going to be a whole lot more in there, but for the informal lab report, you can put in whatever you want to. If you're actually doing it to get practice, then you want to do it the same way you're going to do your formal lab reports. And that's where, let's see, this is the one that says preparing lab notebook pages for inspection. This tells you the stuff that, and let me go to contents and show you where all this stuff is. Because like I said before, everything that I hand out in class is duplicated in Brightspace. So where would you find this? There's a syllabus and all that's typical stuff. So we would go down to lab exercise modules right here. Okay. And on the left, the first one you come to is graphing techniques. We don't want that. We want lab notebooks. Sorry. So prep instructions. Here you go. Lab notebook pages, prep instructions. And there's looks just like this. So for the third lab, this is mandatory. For the first and second lab, it's voluntary if you want to put them in there just to get practice. Table of contents, put that in your table of contents, the title and the page it starts on. You need that. Then you go to that page and put the title in. Then there's usually an introductory statement, like what's the lab for? Why are we doing it anyway? And then safety concerns. And you put these in as headers. You would write, you'd have the title on that page, whatever page it is, say it's on page 5. And then you would have introduction. And you'd have stuff here. And then you have safety and safety concerns. Try to organize it so you can find it later, right? The whole point of having a lab notebook is a permanent record of what you're doing and what you've done in the lab, so that either you can go back 6 months later and repeat the experiment, or if you're at a company and you're keeping a lab notebook as required by all competent research institutions or service institutions, you keep a lab notebook. If you leave, the notebook stays. That notebook belongs to the company, so that somebody that comes in behind you can pick up where you left off. And you want enough information when you're writing these out for formal labs, you want enough information in there so that you don't have to go back to the hard copy. It's right there in your notebook, and you can follow along. You can repeat the experiment and hopefully come up with similar results. So you want to know about safety concerns. Sometimes the safety concerns will be in the hard copy and say safety, blah, 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 blah. Sometimes not. Sometimes you have to read the procedure and say, and keep in mind, where are the hazards? And put those in safety concerns. Okay. Then you want materials. That's everything that you're going to use in the lab. Chemicals, equipment, but disposables of any kind. Anything you're going to need goes in materials. Then procedure. Now I'm going to have to skip over here, procedure. Okay, and then you'll have 1, 2, 3, 4. And the way you write it is do this. Weigh such so many grams of something. And in the procedure, you don't have to put exact values, right? If you're supposed to weigh out 10.5 grams of sodium bicarbonate, then you say weigh out 10.5 grams of sodium bicarbonate. But when you actually do the weighing, you get a different number, slightly different, maybe 10.4963. You know, that goes in the data section. This is just instructions on what to do. Okay, that's your procedure. Then there might be some pre-lab questions. Pre-lab questions. These are to be done before you walk in the lab. All of this definitely is to be done before you walk in the lab. These are to be done and answered, pre-lab questions. Then you just reserve space for data observation. Space in here. Now you can organize it any way you want to. If it's a very simple experiment where you're going to do this and measure that, measure that, measure that, and only have one value for each one, then you can have a list here of what that is, and then something here and the units of measure, and then something here, maybe milliliters here. You can do it that way. If you're going to have an experiment that has lots of data to be collected and it's organized, the best way to organize it's in a table. So you would set up a table and say you're going to do it. Repeat this experiment 3 times. Call them reps. Right? You have 3 reps. You're going to have something here, and you're going to have rep 1, rep 2, rep 3, those values. And then another here. And organizing in a table allows you to know if you've goofed up, if you skipped a step. Right? If you lay it out like this or like this, and you have set it up so that you're supposed to put numbers in there, or you're supposed to put observations in there, and you get down to a step in your procedure that goes in right here, and these are blank, stop. And why are they blank? Were they blank on purpose? Okay, if they're blank on purpose, then just X them out. But if they're not supposed to be blank, then you skipped a step. And you better stop now and go back. Okay? So that's what you do with your data. You set it up so that it helps guide your procedure. Now, these are the steps of your procedure. And you don't go to this for steps in the procedure, but this tells you if you've skipped a step. Okay, it all fits together. So that's reserved space. Then reserve space for calculations. Some procedures that we're going to do have lots of calculations, and some have very few. Some have none. Right? But reserve the space for calculations. And this is on a step, just, and you've got lots of room in this notebook. Right? What have we got? Seven. We got 7 experiments set up, and 2 of them are non-informal. So you got lots of room in that notebook. You can spread it out as far as you want. Then you want to reserve space for summary and conclusion. And this is usually the one that gives students the hardest time because they're trying to think of something profound. It's just summarize what you did, right? And the results that you got. And then the conclusions are, what does it mean? Right? Maybe it doesn't mean anything to you. Of course, it should mean something to you because that's worth points. And here's where you can use the rubric sample. But I didn't give you a sample rubric, but there's one here on this sample report. This shows you what I'm looking for. Highest points are over here. So if you look down here, you say conclusions and summary. Right? So you get the most points for having this in that paragraph. And then sometimes, not always, but sometimes, there will be post-lab questions. Okay. And that, you just need space for that. Right? Those are to be done after the lab. So this is reserve space, reserve space, reserve space, reserve space, completed, 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 completed. That's what I want to see for the formal labs, right? Beginning with lab number 3. So when you come into the lab, you bring your notebook in, and I'm going to check your notebook to see if you've got all this stuff in there for that lab that day. Right? And I'll try to produce a quantitative assessment, and I'm looking for 80% or better. So if you're missing a section, that's like 10% off. So if you're missing 3 sections, you get 70%. You got to sit this one out, right? You're a hazard to the class. If you're not ready for the lab, that's signaling a hazardous student. Right? That's the first and most important tool for being safe in the lab is know what you're going to do before you go in there. Right? This is not a cooking class where you can go in and just throw stuff together. And, this looks like it might taste good. Throw it in there. Right? In chemistry lab, it's a little more regimented. Right? You need to know what you're going to do ahead of time because there are some chemical reactions that are violent, right? Extremely exothermic. We're not going to probably have, well, may not have any of those. We try to give students safe labs, especially for the first chemistry lab they've ever had. But you want to behave as if there are hazards and be especially careful. And that's the way you do it. So this document tells you what I'm expecting to see. And I think on the back of this page, there's more detail, right? It's the same stuff here, but details on the back. Okay. So for the first 2 labs, you can do that. You can put that in your lab notebook. I'm not going to check that one. If it's there, it might be valuable for helping me assess your abilities in the class, but it doesn't have to be there. Only the formal lab reports need to be ready for. Although for the informal, of course, the one we're going to do today is we're not even going to go in the lab. We're going to learn how to graph. But the one where we go in the lab and do lab techniques, you do need to read the lab. You know, I may give you a pop quiz or something just to see if you've read it because there are potential hazards in that one. Bunsen burner. Like, everybody used a Bunsen burner before? Maybe, maybe not. Right? That's an open flame. Right? Right? You want your hair flopping around, ready to just go through the flame. Loose clothes. Or later on, what if you spill something that's corrosive? Like you want to have a lab coat, you want to have your legs covered, you want to have solid shoes, preferably leather, but fabric's okay. Something you can get in and out of real quick. But you want to protect every part of your body. We're not going to have such dangerous experiments that you need full goggles, right? Those wraparound shatterproof glasses will work. We have goggles in the lab, right? But they are so old, some of them are kind of scratched. If you want to get a pair of your own, that's fine. I've got a few pair that I can loan you. And they're big enough they can fit over your glasses. Wear glasses. Okay. Stop me if you have questions. Let's see. All right. Let me go back. It's fine. Breadcrumbs. Yeah, there's breadcrumbs. Another good document to have is when you start to prepare a formal lab report. And the reason I want you to set up your lab notebook in that format is that's the format for the formal report. If you've got your notebook set up properly and you got the information in there, calculations and all that stuff, then writing the report should be easy. There are only a couple of things you need to watch out for when you write your formal report. One is readable, right? Needs to be typed, and there are pitfalls in writing a good lab report, and that's why I've got this common errors in preparing a formal lab report. This should help you avoid common problems, so at least read it once. And you got the sample lab. This one is Boyle's Law. We'll do Boyle's Law later, but let's give you the outline. And you can see that even this student's report had corrections in it. One of the better ones. I got permission before I blanked out personally identified them. Setting up your lab notebook. This is an example, right? Students writing legibly. These are not, these don't have blank pages in them. So if you look at the top, you're going to see the numbers are in order, but not directly sequenced because we left out the blank. Does everybody know, heard the term plagiarism? English classes, history classes where you have to write term papers, plagiarism is usually well understood. You understand what to do. You cite your sources. You don't claim cracks of text as your own when you copy them verbatim out of some other source, right? But when you're working in the sciences, it may be a little more cryptic as to what plagiarism is. Some scientists, I think, understand what it is, but they choose to ignore it. Right? And eventually they get found out. Their careers are crashed. But some actually write things that they don't understand that you are plagiarizing. if you don't give somebody credit for work that you didn't do, that's here we go. That's why I put this document together. I didn't have this in the beginning until I started seeing plagiarism reports. It's fairly easy to know when you're plagiarizing something that's published. That's simple. But if you're copying your lab partner's answers and claiming that they're your own, that's plagiarism. These conclusions that you draw need to come from right up here, right? And for your own benefit and for my benefit, I don't want to grade two papers that are identical. I want them to be demonstrations of your abilities, because I've got to give each one of you separately a grade. And if I see that probably the worst example is I had a class where husband and wife were taking the class, and they plagiarized like crazy. I guess they didn't figure there was anything wrong with it. And it's a group effort, but I had to explain it to them. Okay. So these common errors will help you avoid problems. Take advantage of technology, right? If you're using Microsoft Word, for instance, it has spelling and grammar corrector in it. Right? Just run it through there. Right? Sometimes, a lot of times, it gets it wrong. Spelling is pretty good, but grammar is not, because it's not built for scientific language. But the spelling, right? You can avoid any loss of points for spelling errors just by running your spell checker. I mentioned the difference between data and procedures. Right? Procedures just says do this. Data is actually what comes out of those procedures. Right? It could be in the form of numbers, usually is numbers with units of measure. And then observations are considered data also. But that's where you put the exact value. That we have a balance that measures to 4 decimal places in grams. Right? If the procedure says weigh 10.5 grams of sodium bicarbonate, and you go to weigh it and you come up with a value that's got 4 decimal places in it, you put that in the data. And my rule my general rule is, if you have equipment that will measure to 4 decimal places of a gram, and the procedure says weigh to 3 decimal places plus or minus, 1,000th, I take as many decimals as I can get, because you can always throw decimals out later, but you can't create them. Right? That's called cheating. So whatever your instruments will give you, keep all those values. Okay. So once you've got all this information in your notebook in that format, then you can write the report, because it follows the same steps. It has the same headings. The only difference is when you get to the procedures, you use different tense. Right? Everybody know what tense and grammar is. Right? We want passive third person past tense. You want to say what happened, but you don't want to personalize it. You want to say, I did this or we did that. No, you want to say something was done. Like approximately 10.5 grams of sodium bicarbonate was measured using analytical balance. Okay. Whereas in your notebook, it'll say, do this. It'll say, measure that much. But when you write your report, you want to say what actually happened, because your report is on what you did in the lab. And you may have had to do something different than is in the procedure. So while you're doing the procedure, if the procedure has to change for some reason, say I messed up and you don't have this chemical anymore, so you cross through it and you write the one that you do have, then when you write your report, you're actually going to say what actually happened, not what the hard copy says should happen. Now, students, it's surprising how many students will actually just take the easy route, go back and regurgitate the procedure from the hard copy. And I have to correct them and say, you didn't do that. I know you didn't do it because I changed something, right? So the report is supposed to say what you did. All right. Let's see. Where do I want to go next? Come on. There we go. Okay. There is an introduction video. You can watch those if you want. There's a section on safety. There's a class schedule, lab notebook, how to, and then the exercise modules. And the rest of this stuff is mandatory from the administration. So here we have each of our lab modules. This graphing techniques, we have a, let me do this as a student because I don't think it's going to let me say what I want to as an instructor. So let's go back to content and down to this first lab. Lab exercise 1. And there's a lab exercise graphing techniques. That's the intro. When it says link, that's usually a link to a video. Graphing techniques assignment. There you go. Assignment. I know it's kind of small up there. So here's where you can get another copy of the procedure. And then down here is upload. So say the syllabus says this report is due on such and such a date. But you come to class and you left it laying on the kitchen table. So before midnight that night, you can make photocopies of it and submit it right here, upload. It's preferable if you can combine it into one PDF file. That'd be better, but I can do that if you can only take pictures. Okay. So, safety. Everybody get a copy of the safety document? Should have, because I'll get a few out. This one right here. Did somebody return one of those to me already? No, sometimes that happens. So these are general rules. I don't think we need to go over every one of them. You should read them. There are quite a few. Read them so that you know what you should and shouldn't be doing in the lab. And then the last 2 pages are duplicates. One of them, fill out one of them for you and one of them for me. It's like a safety contract. And you can do that between now and the next time we walk in the lab. You don't have to turn it in now unless you want to. So let me see, is there any information in there that I can give you? No, this is all your stuff. We want to know if you have any medical conditions or allergies. I've had some students with severe allergies. Some of them were pregnant, right? Needed to know if we were going to do anything hazardous, right? And I specifically choose these experiments so that they're not hazardous to the unborn. Okay. If you want to do those now, I can